1.7 Simplifying Fractions Part 2. So we started by basically looking only at multiplying and dividing with fractions and variables and what can you do with those things and how do you approach it. You can also add and subtract fractions, and that takes a little more work, so we're doing that second. Just like with regular fractions, you will have to make sure that fractions have a, and hopefully you are thinking common denominator, right? And creating the common denominator isn't always as easy as it might be with just numbers. So we'll go through 4 examples and they will build on each other a little bit. Okay, sometimes it is just as easy as with fractions that just have numbers. So if you have one denominator of x and one of y, one quick way to make common denominators that you've been taught in the past is that you use this denominator over here. So you do y over y, and this denominator x over x here, keeping in mind that x divided by x is just 1, y divided by y is just 1, so we're multiplying here by 1, so we're not changing anything, we're just rearranging the way that things look, and that should allow us to create two fractions that will have the same denominator. So 2 times y is 2y, and then in the bottom, in the denominator, you get x times y, and x times 1 is just x, and then y times x is also xy. So I'm going to write it in the same order. So same denominator, so that means that ultimately you can write this with one denominator, and the first part of that will be 2y plus x. And so here's one big difference already. When you do this with fractions that contain variables, usually you end up with a polynomial here that may have 2 or 3 terms. It just depends on how big of a mess we start out with. Okay? I'm going to approach this slightly more organized now. So in this example, the first denominator is 3x, which is just 3 times x. So what I'm doing, or what I'm going to do, is I'm going to break this down into the prime factors that are in each of the denominators given. So the prime factors. So, 15y, well 15 is 3 times 5, and then y is just y. Now the common denominator will have all of these factors represented. So from the first one, I do need a 3, and I need an x. For my second denominator, so the second denominator is split out here, I need a 3, but I already have one 3. I need a 5, I don't have that yet, so I'm going to add, I'm going to include a 5 in here, and I need another y. So this is your common denominator. So what I just created will be the common denominator for the fraction that we're working on. So that denominator should be 3 times 5 is 15 xy. Okay, because this involves a lot more writing, but if you do it organized, you can actually sort of skip this step. So I don't usually do this step. I still sort of do these things over here and over here, but you'll see that here in a second. So I already know I'm going to get 15xy over here. What I'm going to do now is I'm going to look at the denominator that is given. So I'm going to take a look at 3x. Okay, I'm going to see which parts do I not have yet. So I have a 3, I have an x, I still need a 5 and a y. Well, then that will be what I'm going to multiply by. Now I only usually write the 5y in the top, but really what I'm doing is I'm multiplying by 5y here and 5y there. Okay, because 5 times 3 is 15, and y times x is xy, so that creates the common denominator. So 2 times 5 is 10, and the y just tags along. Immediately go ahead and copy that thing. Okay, so we're going to copy the symbol in between, whether it's adding or subtracting, just copying it. Now I'm going to do the same thing. I'm going to look at the second denominator, which is 3 times 5 times y, and I'm going to look at which parts do I already have, and what do I still need then. So I already have a 3, right? I have a 5 and I have a y already in 15y. So what I still need is this x. So I'm going to multiply by x here, and I will multiply by an x there as well. Although usually I don't write that one. So what do you get? You get 15xy in the bottom. Great, I already knew that. And 1 times x is x. So then your final answer would be, I'm going to try to write it a little neater over here once. So your final answer looks like this. Okay? So I'm going to do that one more time. Actually, I'm going to do it twice. So same thing. So start with 3x. And we'll start with red. So 3x is just 3 times x. And it seems sort of silly to write this. But, after you do this a couple of times, there are some shortcuts you can take, and hopefully you'll find those yourself. So 15 is 3 times 5. X squared is x times x. And then y. And then 2, well, that's a 2 over 1, isn't it? So that denominator really has absolutely nothing yet. Okay? So let's look. What do we end up with? So I need a 3. I'll need 1x. I have a 3. I need a 5. Don't have that yet. I need 1x. Actually, I need 2 x's. So I'll need one more x. So the first x counts, but you do need a second one to get an x squared at some point. And you need a y. And then over here, 1 is just 1. So multiplying by 1, you don't really need. So what do you end up with? Well, that means that the common denominator you end up with is 3 times 5 is 15. X times x is x squared. And then a y. So what happens? So now let's look at the top. So we'll do that one in blue. So the first one, I have a 3 and an x. So I have a 3 and an x. I still need a 5, an x, and a y. So this is one step that I usually skip. So I'm just going to use a 5x and a y. 2 times 5 is 10. And then I get an x and a y. Keeping in mind that I really did do the same in the bottom, that if I do 3x times 5xy, I end up with the denominator that I already have. Minus. Let's see. I need a 3 and an x, so I got a 3 and an x. I need a 5, already have that. I need another x and another y. Well, this denominator is exactly the same as that one, so you do not need anything here to create a common denominator, so you can just copy the minus 1. Copy the plus for the 2 over 1. Okay, the over 1 needs everything, right? I need a 3, an x, a 5x, and a y. I don't have any of those, so I'm going to multiply 2 by the common denominator. So I get 2 times 15x squared y. So 2 times 15 is 30 x squared y. And then that's what you do. And then hopefully it's starting to make sense a little bit. All right, one more. And I'll tell you here in a second exactly why I put this one in here. So 5m squared k cubed. Right, so I don't need a 5, I need an m, I need another m, and I need k 3 times. For 3x, I need a 3 and I need an x. So what's the common denominator? Well, I need all of these, so you can really copy that first one, right? 5m squared k to the third. I need a 3. I don't have that yet. And I need an x, and I don't have that yet either. So the multiplication of all these things is your common denominator. And I wrote that a little too large, so I guess I'm going to put that over here. So 5 times 3 is 15. M squared k cubed x. All right, so what do we have? The first one has a 5. Got that, got that. I need an m squared. I already have that. And I need a k cubed, so I have those 3. So you need to multiply by 3x in the top. Now, it doesn't matter at all what the numerator already has. So you do need to multiply here by 3x. The fact that it has a 3 and an x cubed has nothing to do with creating the common denominator. Because keep in mind, and I'll write this one in front once, that really what I'm doing here is multiplying by 3x and multiplying by 3x so that in the denominator you get the common denominator, so that means you should do it in the top as well. So don't let this confuse you. 3 times 3 is 9, and then x cubed times x to the first is an x to the fourth. And the same thing happens in the second denominator, right? We have a 3x already, 3x and 3x, so what do we need? We need a 5m squared k cubed. So just copy that, 5m squared k cubed, and then worry about what other stuff do we have. Well, we already had a 4, and so 4 times 5 is 20. Notice that I just copied the subtraction symbol. M to the first times m squared is m cubed, and k cubed times k cubed is k to the, we adding, right? 6. So when you multiply, you add exponents. So that would be the numerator. Okay? So the numerator does not influence what you multiply by at all. All right. Well, that's it. Other than, let's summarize a little bit here. So what did we do? The first step is that we break down each of the denominators, right? We break down each denominator into primes. so that we can figure out what parts do we need in the common denominator. Okay, and so we represent each prime. So we represent each prime factor from step 1 in our common denominator. Oh, it just fits. Okay, and then after that we use the common denominator to find the missing parts, right? So we're going to find missing parts for each individual term's denominator, and I'm not going to fit that in there. And then we use those as factors for the numerator. Okay, so then that is the last step. So that one's a little wordy, so let me see if I can run through the steps a little bit here. So break down each denominator in primes. So this was step 1, right? What then we said, represent each prime factor in the common denominator. So this is step 2, right there. And then the wordy part says, find missing parts for each individual term's denominator and use these as factors for the numerator. So step 3 is really over here and over here. This is what we compared the common denominator to the individual denominators. And that's how this works. Thank you.